How's it going? We're Group 18 and our topic is extraterrestrial life possible on Europa? Now Europa is a moon of Jupiter. It's the sixth closest moon to Jupiter, and coincidentally it's the sixth largest moon in the solar system. Curiously enough, its mass is also larger than all the other moons in the solar system combined, and smaller than itself. It was discovered in 1610 by Galileo alongside the three other largest moons of Jupiter, Io, Ganymede and Callisto. These are known collectively as the Galilean moons, Europa being the smallest of the four. It's only slightly smaller than our moon. It's named after a Phoenician noblewoman called Europa, who is the daughter of Tyr and was courted by Zeus and became the queen of Crete. I do say courted, but what I mean is Zeus kind of turned into a ball and then had his merry way with her. That's just Greek mythology then. Along with Europa, it was also called Jupiter 2 for the longest time, meaning Jupiter's second moon. It wasn't until 1989 when NASA launched the Galileo spacecraft from the space shuttle Atlantis that other inner satellites were found, and it was moved to being the sixth moon, although it's still sometimes referred to as Jupiter 2. There's another probe on its way, this one called JUICE, or the Jupiter Icy Moon Explorer, which is being launched in 2022 by the European Space Agency. The curious thing about Europa is that its surface is completely covered in water ice, making it the smoothest object in the solar system. Not only does this help with how Europa can pick up, but it also suggests that below the smooth icy surface is liquid water, and it's found that there's actually more liquid water on Europa than there is on planet Earth. Which begs the question, is extraterrestrial life possible in the under ice oceans of Europa?
As many say, there's water, there's life. On Europa, one of Jupiter's moons, there's believed to be a water geyser on the south pole of Europa. Researchers and scientists believe that there is a possibility of having sustainable life on Europa. Scientists have detected transient plumes of water vapor that erupted nearly 125 miles or 200 kilometers into Europa's atmosphere. Researchers have also discovered spikes in hydrogen and oxygen levels in two regions of Europa's southern hemisphere. This shows that there's oxygen in the ocean beneath the ice, which as far as we know is essential for life. Without this phenomenon, scientists will only believe that the moon was 12 million years old. Due to the combination of the geysers and the lack of atmosphere, the surface is smooth, giving way to the notion that the moon is relatively young. If in fact the moon was so young, then the odds of life being under ice would be slim to none.
How is there liquid water on Europa? That is the all-important question. The way things stand, where there is liquid water, there is life. So, how is there liquid water on a moon outside the Goldilocks zone? Well, there are a couple of factors that are believed to keep a liquid ocean under the ice. One source of heat is due to Europa's proximity to Jupiter and its other larger moons. There's a constant gravitational tug of war pulling back and forth on Europa, pumping energy into it. This is called tidal flexing. This is just like when you hit a squash or a racquetball, causing the ball to flex and warm up. Another potential source of heat was found by a study done by scientists from the University of Texas Institute for Geophysics and the Georgia Institute of Technology. This study showed the evidence that there are Hadley cells forming under the ice. The significance of this meteorological pattern is that heat will spread from the equator towards the poles and from the seafloor to the surface. The heat itself will originate from the core of the moon and then rise to the equator. Not only would these Hadley cells cause the spread of heat, it will also facilitate the circulation of nutrients which may be essential for life. This provides some proof that the oceans on Europa are similar to that of Earth's.
Predictions of extraterrestrial life exists on Europa have ensured a high profile for the moon and have led to increased backing for future missions. The aims of these missions have ranged from examining Europa's chemical composition to searching for extraterrestrial life in its speculated subsurface oceans. Europa receives about 540 rems of radiation per day. Therefore, robotic missions to Europa need to be able to endure these high radiation environments. On Earth, we generally believe that if humans were exposed to about 500 rems of radiation, that they would likely die without immediate medical treatment. In comparison, humans on Earth are only exposed to about 0.000014 rem, much smaller than what is present on Europa. The intense radiation around Jupiter is the source of the radiation that we see or measure on the moon Europa. Now, the high energy particles from the radiation can damage space probes and, of course, destroy biological molecules or other signatures of life that may exist. However, new project plans to create a radiation weather map will help pinpoint regions where astrobiologically relevant molecules may survive. With that said, any possible life on Europa would have to exist under the ice that shields these life forms from the radiation. This would thus make Europa one of the most likely candidates for life in our solar system today.